Hey, it's Mr. C with your Saxon math for today. We're doing lesson 97 on transversals. Now, this is a new concept that we haven't done before. It has to do with different angles, and so we're going to look at different angles when we have two lines intersected by another line. So that's what we'll do with transversals. We're going to look at identifying interior angles, alternate interior angles, alternate exterior angles, and corresponding angles. And then we'll find the measure of angles formed by a transversal intersecting parallel lines when the measure of one of those angles is known. Now, this is something that you'll continue to do in math. You'll see this on tests, again, like your ACT, SAT, those kind of big tests that you have. These kinds of problems show up. So this is something that's really good to know, not just now, but in the future for testing things. And the reason why it shows up on tests is figuring out angles is something that we use all the time in architecture and building things and putting things together. And so it's good to know about transversals and how to calculate what different angles are. All right, so a line that intersects two or more lines is a transversal. So here we have not parallel lines. In today's problems, we're going to be dealing with parallel lines. But here we've just got two lines intersected by another one. So we've got lines S and T are intersected by line R. That's a transversal. Here we have two parallel lines, and then they've shown all the different possible angles. If we have a transversal, that's one line intersecting others. So we have all these angles inside. Here we've got our exterior angles. That's the outside of the transversal. So the outside of the two lines. The inside of the two lines is the interior. So it makes sense. Exterior is the outside, interior is the inside. So we're going to look at these different kinds of angles. Now with this, we've got 4 obtuse angles, 1, 3, 5, and 7, and 4 acute. Remember, obtuse is more than 90 degrees, acute is less than 90 degrees. So 2, 4, 6, and 8 is less than 90 degrees. And you can see that just by looking at it. That's less than a right angle, whereas 1 is greater than a right angle. So that totally makes sense. So here, if we look at angle 1, the obtuse one, and acute angle 2, together they form a straight line. If we put those two together, all we've got is this whole area, which is 180 degrees. So that's supplementary. So if we know that 1 is 110, and we know the total is 180, we can subtract 110 from 180 and know that number 2 is 70, because that's 180, the whole line, minus the one angle, which is 110, equals 70. That totally makes sense. All right? So notice that 2 and 3 are also supplementary. This is a line, and 2 and 3 come between it, but if we take this line out, that's just a straight line. So we know that these are also supplementary angles, and we already know that 2 is 70, so that means 3 has to be 110, because 70 and 110 equals 180. Knowing that, we can figure out what all these angles are, right? So we know that if this is 110, then this is 110, and this is 110, and this is 110. And 2, 4, 6, and 8, those will all equal 70. So that will help us have all of our supplementary angles. So here we're looking at it up at the top, and we're going to look at corresponding angles. So 1 and 5 are corresponding because they're in the same position. Those angles are in the upper left of the intersection, okay? And so the upper left angle are corresponding angles. 2 and 6 would be corresponding angles. 7 and 3 would be corresponding angles. So you can find all those different corresponding angles. So which angle corresponds to 2? Which one's in the same position? If we look down here, it would be 6. Which angle corresponds to 7 in this position? Up here it would be 3. Okay? 7, oh, and 3, yep. Okay. So now, since lines in M and N are parallel and P intersects it at the same angle, we can figure out all the different things. So if 1 equals 110, we know that 5 equals 110. We've already gone through this. The interior angles are the angles between the parallel lines. So these 3, 4, 5, and 6 are all interior angles. 7, 8, 1, and 2 are all exterior angles. The alternate interior angles, that's angle 3 and 5. 3 and 5 are alternate interior angles. That means that they have the same angle, just as 4 and 6 have the same angle. That's alternate interior. Alternate exterior would be 1 and 7, 8 and 2, because they have the same angle. I'm going to skip all this. We've done it. All right, so the thing that you need to remember, here's the key. When a transversal intersects parallel lines, all acute angles formed are equal in measure, and all obtuse angles formed are equal in measure. Just like we saw in that example, all the obtuse were the same, all the acute were the same. So now we can look at this. What are the pairs of corresponding angles? What are the two that if you add them together, oh no, that's a supplementary angle. Corresponding angles, that's your A and E. So here we have A and E. It's the same position, remember? So A and E are corresponding, B and F, C and G, D and H. Those are our corresponding angles. What are the alternate interior angles? Those are the ones that have the same. So D and F, C and E. What are the alternate exterior angles? G and A, B and H. And if the measure of A is 115, then what are the measures of E? That's complementary or a corresponding angle. So A and E, 115 equals 115. And the measure of F, that would be a supplementary angle. So add them together and equals 180. 115 subtracted from 180 equals 65. So that's what that is. And here's all our answers. Let's make sure we got them right. 115 and 65, that's great. And here's your practice set. Some new vocabulary on this one, some new ideas that we haven't looked at, but practice it and you'll get it. So just keep working through it. Good luck.